So I'm going to be teaching my brother action potential and muscle contraction. So everything starts up here with the neuron. So stimulus is going to be received through these dendrites, and then that stimulus is then going to go to the soma, which is this part right here. And the soma is going to determine whether or not the impulse is strong enough to send to the rest of the neuron. And if it is, it's going to go to this little section right here called the axon hillock, and then it's going to trigger something called the initial action potential, and it's going to send the signal all the way through the axon into this part right here, and it's going to so this part is called the axon terminal, and in here acetylcholine, which is a neurotransmitter, is going to release into this space called the synaptic cleft. And when it releases into the synaptic cleft, it's going to bind to these little gates right here. And these are called the ACH gated channels. And they're on the muscle membrane. And this is going to allow sodium ions to go into the muscle cell. So when sodium enters, it causes something called local depolarization, which is an electrical charge that makes the spot more positive, and this also activates something called the voltage-gated sodium channels to open. Um, this is all going to create an electrical wave called an action potential, and it's going to travel through the muscle fibers, and it's going to travel through almost like a light switch where positive is out, positive ions are out, and negative ions come in, negative ions go out. So it's basically like a light switch going down. And so it's going to travel across the muscle fibers, and as this wave moves along, it's going to cause something called depolarization of the muscle membrane into the inside of the muscle cell. So the depolarization is going to open something called voltage-gated calcium channels, and this is going to then tell the sarcoplasmic reticulum to release calcium ions, and when it releases it, it's going to trigger the next part, which is the muscle contraction. Okay, so muscle contraction. So if you were to get like a really microscope and look really deep into your muscles, you're going to see these little sections called sarcomeres. And so this is what a sarcomere looks like when it's relaxed. So this is when your muscle is not contracting. It consists of this M line, these this line right here with the little attachment is called the myosin filaments. It's going to have a Z line, and attached to that is going to be something called an actin filament. And so when your muscle contracts, the goal is to get the actin filaments to get to the M line. And if you zoom into even more, you're going to get this image right here. And this is the actin, and then down here with the little bean sprout thing is the myosin. So when the calcium ions attach onto, well, they get released and then they attach onto the actin filaments, it's going to then move this line right here called the tropomyosin out of the way, and this is going to allow myosin filaments to be able to grab onto the actin. So it's going to let this grab onto this, and it's going to enable something called a power stroke, and it's also going to release phosphate when it does that. So the power stroke, it basically slides the filaments towards the M line, so it brings the Z lines closer, and this shortens the muscle. And in order for this to happen, myosin needs something called ATP. ATP is almost like a charged battery that's going to attach onto the myosin, and it's going to enable it to have that power stroke. And once it does that, it's going to release something called ADP and phosphate. And ADP, just like ATP is your charged battery, ADP is kind of like your battery that's already used. So it's going to release that. And in order for this myosin filament to activate again to power stroke, it's going to need more ATP. So once the neuron stops sending signals, there's going to be no more acetylcholine released, and the electrical activity that moves down the membrane is going to stop, and then sarcoplasmic reticulum is going to pull back all the calcium ions, and that's what's going to cause this whole muscle contraction to stop. So like I said, it all starts here, and it all leads down to this muscle contraction, and yeah, that's it.
Yeah.